Hello, good afternoon, and good evening, everyone. Welcome to our Cloud Lunch and Learn session. We are going to have a very good session today regarding Azure AI and Semantic Kernel. It's going to be about applications and different Azure AI source that you can bring together, especially with that open source project that our very known speaker Håkan is going to share. He is also Microsoft MVP in AI area, which makes it even more exciting. So welcome to the studio, Håkan. How are you?
Yeah, thank you so much. I'm doing really great. How are you?
Doing well, thank you. We had a few chat here about the place from where Håkan is joining. He's joining from Oslo, and it's coming to that sweet time when the summer hitting the Scandinavia, where the beautiful spring and everything is there. So that's awesome place to be. And without any overdue, I want to bring back the session here and give the stage back to Håkan. He's going to introduce the session and speak about this great stuff that's happening on Azure AI front. Back to you, Håkan.
Yeah, thank you. Thank you so much. So first of all, I want to thank all of you who have decided to spend the next 45 minutes to 1 hour together with us. So I'm going to be talking here about AI agents and how you can enhance your own AI services using a semantic kernel. So this session will be quite demo focused. So I'm going to show you first of all like a finished application, and then I'm going to sort of trace back into how did we do to develop this application, how did we do the prototyping, what kind of tools and frameworks did we use, and then we're going to go more into a specific framework called Semantic Kernel that you can use in order to build AI agents. And we're going to also have some demos on Semantic Kernel just to show you a little bit about what you can do with it. But before we start here, I would just like to take a moment here to say a couple of words about me. So I work as an AI evangelist for Soprasteria in Norway, and I'm also a Microsoft AI MVP for the 5th year here in a row. And I'm also a Microsoft Certified Trainer and the Microsoft Certified Trainer Community Lead. And you can also find a little bit more information about me on this slide here. And at the end of the session, I will share some QR codes, both to some learning resources on MS Learn and also to some GitHub repos where you can download the code and try these things out yourself. And finally, I also have a QR code which links to my LinkedIn profile. So feel free here to connect if you want to follow me on LinkedIn. And also, I'm also quite engaged here in the local user community in Oslo. So I'm part of the organization committee for the Norwegian.net user group, and also for Oslo AI, which is also a meetup focused on AI. And during the Corona, me and 2 other AI MVPs, we started our own AI school on YouTube. So you can find us on AI42. So there you can find all kind of information if you want to get started in machine learning or AI. And finally, I'm also part of the organization group for the Azure User Group Sweden that I ran together with Jonah Anderson, who is an Azure MVP from Sweden. So the agenda here today is I'm going to talk about AI assistants and also AI agents and talk a little bit about what is the difference and when does it make sense to use one or the other. And then we're going to dive more deeper into a specific framework called Semantic Kernel and also a tool called Prompty. And there will also be many types of demos, both in Visual Studio Code and in Visual Studio. And at the end of the session, as I mentioned, I'm going to show you some learning resources and some links to some GitHub repos and also a QR code to follow me on LinkedIn here. But before we start, I would just like to show you an application that I did. So let me switch over here to my browser. If I can find my browser here. One moment here. Yes. So before I start with that, I would like to give some context here. So even though I live in Norway, I am from Sweden. And in Sweden, we have this tradition around Christmas to create something that we call a Christmas rhyme. So when you're going to hand out your Christmas gifts, then what you do is the week before Christmas, you gather together and then you write like a Christmas rhyme about the gift that you're going to be giving away. So the Christmas rhyme is in a specific structure and it will give you some hints about what is inside the package without totally revealing it. And in addition to that, you also add an illustration here of the gift. So I was thinking here that maybe I could use AI in order to help me come up with a good Christmas rhyme and also in order to help me to come up with an illustration. So let me show you here how the application looks like, and then we're going to go through the different parts here throughout this session. So the main idea here is that you can choose a specific gift that you want to give away. So let's say that I want to give away a book here for Christmas. So now I select my book as a gift, and then I can create a Christmas rhyme here. So if I have a look here, then it says here, in pages bound, new worlds await. A journey starts, oh, what a fate. With cozy nights and tales to weave this gift of a book, I hope you believe. Merry Christmas to you, dear friend. With each story, let your heart transcend. And then I can also get an illustration here. So sort of behind the doors here, what is happening is that I've set up an Azure OpenAI instance, and then I have deployed a GTP4 model that I can use in order to create this Christmas rhyme. And then I've also deployed a DALL-E 3 model that I'm using in order to create this illustration here. So we can see here in the illustration that it's very Christmassy. It has bright red colors and snow, and it also shows Santa Claus and also this gift that is supposed to be given away here. So I'm going to show you in a while here how we can create an application like this. But this is sort of the end result where we want to get to here. So now when we've seen this thing, which is like an appetizer, we can go back here to my PowerPoint presentation. So what is the difference here between AI assistants and AI agents? So if we look back here in 2023 and 2024, there has been a lot of focus on ChatGPT and on copilots and these kind of things, and they are examples of AI assistants. So what is typical for an AI assistant is that it's a conversational AI. You're using some sort of chatbot in order to communicate with it, and that you're also using prompts here in order to send information into the assistant. And then what you get back from the assistant can be a recommendation. The assistant can suggest information based on the type of data that it has access to, and so on. But then AI agents, on the other hand, they are much more self-sufficient. So they don't require a prompt from you in order to do their work. But instead, what what you can do is that you can give an AI agent a goal, and then the AI agent can both plan and develop their own workflows in order to reach that goal. And an example of this is, for example, if you have a scheduling problem, maybe you have you have a fleet here of trucks with different loads that they need to pick up, and they also need to deliver on specific times. And then you also have a number of drivers that should be assigned to particular trucks here. So this is a classic scheduling problem. So what you can do here is that, granted that you have some functionality in order to retrieve the schedules from the trucks and from when the workloads should be delivered, and also when the drivers are available, then you can create one or several AI agents that can collaborate in order to find out the optimal scheduling for that problem. So the main idea here with the AI agents is that you don't need to do the programming, but instead you just need to you just need to be able to specify a goal to the AI agent, and then the AI agent will be able to figure out what kind of functions do I need to call in order to achieve this goal. So we're going to have a look at some examples here, so things will be clearer here in a short while, how this goals and how this planning works out in reality. So one of the frameworks here that we can use in order to create our agents is called a semantic kernel. And what is special here about semantic kernel is that you can develop a semantic kernel in either Python, Java, or .NET. So many of these agentic frameworks are typically mostly in Python. But if you are a .NET developer, then you can be rest assured that you still can create this type of applications using C# and .NET and using the semantic kernel. So in semantic kernel, we have a concept that we call plugins. So plugins is code snippets that perform a specific function. And then what you do is when you have written the plugin, then you can mark up your plugin so that the semantic kernel can understand what does this plugin do. And they will use that information in order to figure out what is the best workflow in order to solve this goal that the agent has been given. And you can also have connectors so that you can connect to other applications. You can connect to OpenAI, or you can do a web search, or you can connect to another API or to some external third-party service. So here we can see some of the functionality here given by semantic kernel and these different languages. So if we have a look at this example slide here, we can see that you get most functionality out of C#, whereas currently Python and Java does not have the same type of functionality. So for example, in this Christmas rhyme application, then we're using the chat completion in order to get this Christmas rhyme. And we're also using text to image in order to create this Christmas illustration. And if we look on this slide here, we can see that the text to image is only supported right now by C#. So then it makes sense to use C# here for our Christmas rhyme application example. And another tool here which can be very useful for us is something called Prompty. So Prompty is an extension to Visual Studio Code. So with Prompty, basically what you do is you can have a much better overview of your prompts. So it's a very easy way. If you install this as an extension to VS Code, then you can very rapidly prototype and try out different prompts just by changing a text file. And I'm going to show you exactly how that is done. So Promptly supports both semantic kernel, but also LangChain and prompt flow. So here is an example here. If we install Prompty as an extension to Visual Studio Code, then we will get the template that we can have as a starting point for our prompt. So in this template, we can see that there are some fields like a description of this prompt and also what is the context. You give some context here to the prompt. You have a system prompt and the user prompt and some other parameters. And you can also set parameters here like max tokens, which are parameters directly into the large language model that is being used here. And then in order to do test out in VS Code, you only need to press this play button up in the top right corner. So it's a very flexible and efficient and rapid way to do prototyping. But if you for some reason don't want to use Visual Studio Code, or maybe you don't have a developer background, then you can also use Playground here. So here's an example here from PromptFlow, where you get the Playground, which is similar to ChatGPT Playground or Azure AI Studio Playground. So here we can more select from drop-down boxes different types of settings here for our prompty file. And this is an example here of how it actually looks like if you're using it in code. So basically what we do here is first we need to have an Azure OpenAI instance deployed. So we need to configure here the API key and the deployment name of our LLM and also the endpoint. And when we have that, we can create a semantic kernel object here. And then we can also specify that we want to use the chat completion functionality. And then we get our kernel object that we then can use and create a function from this prompty file. So basically from this text file that I showed you before, this prompty file, the semantic kernel will be able to create a function that you can run, or that semantic kernel can run in order to achieve specific types of functionalities. And then we can execute or invoke this function here by just calling invoke and the kernel, and we can also give arguments into that function. And then we can print out the result here that we got. So then I think it's time here to go over to Visual Studio to do some examples here of semantic kernel. So let me switch over here to Visual Studio one moment here. Yeah, maybe one thing that I would like to show you before we do that is this thing here. So I would just like, just for clarity, show you how we can set up this thing here from the beginning here. So the first thing that we need to do here is we need to create a resource here in the Azure portal. So if we search here for Azure OpenAI, then we can see here that we basically here can create an Azure OpenAI resource. And just like most other resources, what you do here is that you select the subscription and also resource group. You need to select the region and the name here for your resource, and also a pricing tier. And if you do all of that, then after a while here, you will get an Azure OpenAI resource, similar here to the one that I've set up over here. So when you have this set up, then you can get the endpoint information, and you can also get your keys here. Right now they are blurred here because of privacy concerns. But basically, so this is what you need, the very first step that you need to do. So you need to have an Azure OpenAI instance deployed that we can use. And when you have that Azure OpenAI instance deployed, then you can go to the Azure AI Foundry. And if you open up this, and we can see here in the Azure AI Foundry, then we can go to deployments. And here in the deployment, in the deployment part here, we can see that I have a number of different models deployed, but basically the ones that we are going to be using is this one, the GTP4 model, and also So this GTP4 model is being used in order to be able to create this Christmas rhyme. And then we have another model, which is the DALI 3 model, which is being used in order to create the Christmas illustration. So I just wanted to show you this just so that it gets more clear what is sort of the prerequisites in order for us to be able to do these things. So let's switch back over here to Visual Studio. One short moment here. So yeah, so I mentioned here that one of the main concepts here with Semantic Kernel is the capability here for us to be able to create plugins. So here we have an example here where we have a folder here called plugins, and then we have also a folder called lights, and then we have created a lights plugin. So the main idea here is that the lights plugins is sort of an abstraction of a physical light. So if we look at the lights plugin, which is just a regular C# file, we can see here that we have properties here for the name of the light and a boolean if it's on or off, and you can also set the brightness here of the light. And then in order for Semantic Kernel to use our plugin, we need to decorate these functions with some information. So first of all, we need to decorate it with this kernel function, so that Semantic Kernel understands that this is a function that I'm able to use, and give it also a name here. And then we also need to provide the description. So the description is quite important because the description is what is being used by Semantic Kernel in order for Semantic Kernel to be able to understand what does this function actually do. And we also need to provide a description here of what is being returned here. So for example, we have this get lights, which gets a list of lights and their current state, if they're on or off. And then it returns an array here of lights. And in similar vein here, we have the get state, so then we can get the state of an individual light. And we can also change state here of a specific light. So then we change the state of the light, and then we return back what is the updated state here of the light. So that's basically it here for a lights plugin. So then if we go over here to our code. So here in our code, what we do is similar to this example code that I showed you in the PowerPoint presentation. We build here a semantic kernel object here, and we specify that we want to use this chat completion, and we provide it here with the deployment name of our LLM model and the endpoint and also the API key. And when we've done that, we can build our kernel object. And then after that, we can add from a specific type here. We can add a plugin here to our plugins collection here that the Semantic Kernel has. So here we're adding the lights plugin so that the Semantic Kernel can use our light plugin for this application. And then there's, furthermore, we need to specify here that we are enabling planning and function calling here for our Semantic Kernel. And then after that, here we create a chat history so that we will be able to communicate here with our agents. So right now we are only specifying one command here, please turn on the lamp. And then after that, we will write out what is the result here or the message here from the agent. So if we run this, I think it will be a little bit clearer here. Yep. So we asked it to turn on the table lamps, and then we get back here an information here that the table lamp has been turned on successfully. So now this might seem like, a pretty simplistic example, but what this basically shows is the strength here of the AI agents, because we should notice here that we as application developers, we didn't need to write, a single line of code here, granted that we have this plugin. So if we have this plugin, we only need to set a high level goal, and then our AI agent is able to figure out what type of functions do I need to call in order to achieve this high level goal. So this can be extremely powerful and save you a lot of development time, especially if you have several different types of agents that are communicating with each other. So in our next example, we can see a little bit more here of the planning here. So let me stop this one, and let me set this as a startup project here. So here in this example here, we still have the Lights plugin, which is exactly the same Lights plugin as before. And what we do here is that we are in the same manner as before. We create our semantic kernel object, and we specify that we want to use chat completion, and we provide it here with our deployment name, with our endpoint, and also with our API key. And then we create or we build our kernel object, and then we add these plugins to our Lights plugin in the kernel plugin collection. And we also specify that we enable planning and automatic function calling. And then after that, we start here a loop where we collect user input, and then we are basically just writing out here what the agent gives back as a result. So let's run this, which will make it a little bit more clear here. So here we can, for example, say here, get the states of all lights. Sorry. So if we ask here, get the state of all lights, then we get back this information here. And then we can ask it to change the state of a particular light. So change the state of porch light. So now the state of the porch light has been changed to on, and you can see here from the previous here that it was off here before. And then we can also do something like this: switch the states of all lights. Yeah, so now we can see here that it actually switched the states of all lights. So the main thing here is again here that now it needs to do some planning, because first it needs to figure out what is the current state of all lights, and then it needs to switch the state of all lights, and then it needs to report back here on what is the new updated state of all lights. So it needs to do some planning in order to achieve this goal. So I think this is a quite nice example here that showcases what you can do with what you can do here with an AI agent, even though it might look a little bit simplistic. So what I would like to demonstrate here is that you as an application developer doesn't need to write code. You just need to be able to specify a high-level goal, and then the AI agent will be able to figure out what kind of functions do I need to call in order to achieve that high-level goal. So stop this one. So if we go back here to our Christmas rhyme application, I'm going to show you how we did in order to develop this, how we started to do prototyping using this Prompty tool, and then how you then can go from prototyping in VS Code over to a more realistic project in Visual Studio. So let me switch over here to VS Code. So now we're switching over here to VS Code, and if I just can do like this. So here in VS Code, what we've done here is we have installed this Prompty as an extension to Visual Studio Code, and then you get the new file extensions called .prompty. So what you can do here is, as I also showed you in the PowerPoint presentation, you will get like a default Prompty file, so that you have a starting point to start out from. So basically, here we have created here a Prompty file for our create rhyme prompt. So we describe here that this is a prompt that uses a gift item as an input and creates a Christmas rhyme back as an output. And then we specify that we are using the chat as the API, and we are connecting to Azure Open API. And then we also need to provide the OpenAI endpoint and also the deployment name to the LLM that we're going to be using. And we can also set some parameters for our LLM, like the max tokens, temperature, and so on. And we can specify what type of format do we want our response in. So in this example, we would like to have the response format in a JSON object. And then we provide it with some context. So in the context here, we say that you should provide a Christmas rhyme for a particular gift, and the rhymes should be in the following format. And then we give it, so in this example, we give it 4 different examples on how a Christmas rhyme typically is structured, so that it can learn the rhyme and how a Christmas rhyme is structured. And then after that, we also provide here a system prompt where we say that you are an AI assistant who helps people with rhymes for their Christmas gifts. As the assistant, you will write a rhyme based on the gift item and answer in a personable manner, and even add some personal flair with appropriate emojis. Respond using the JSON format by including the original gift and the rhyme. So then we can, so nice thing here is that then we can try this out there by running it from here. Oh, here's actually looks like it looks unfortunately that it there may be some that was a little bit strange here, but I can show you here at least the second Prompty file is working. There must be some misconfiguration for the first Prompty file. But basically here with the second Prompty file, we would like to create this Christmas illustration, the image. So what we write here is that this is an image prompt. It's a prompt that uses a gift item as an input and creates an image prompt back as an output. So basically what we do here is we are using the LLM in order to create an image prompt, and then we're sending this image prompt over to the DALL-E 3 model in order to create the actual graphic or the actual illustration here. And in a similar way here, we say that we're using the Azure OpenAI, and we provide the OpenAI endpoint and the deployment name and some parameters here for the large language model. And then here we specify in the context that you should take a gift item as an input and turn that into an image prompt for DALL-E 3. And we can also specify some more requirements here for our image. So we say that the image should always be Christmas themed with a lot of red colors and winter details in it. There should be either Santa Claus, reindeers, or the Santa Claus dwarfs in the image. And in the system prompt, we are saying that you are an AI assistant who helps people with illustration for their Christmas gifts. As the assistant, you will write the prompt that DALL-E 3 will use to generate the image. Respond using the JSON format by including the original gift and the image prompt. And then we can try and run this here. So then we can see here that we had here a book as the gift item, and then we get an image prompt here where it says that the beautifully wrapped book sitting under a decorated Christmas tree, surrounded by snowflakes and twinkling lights. In the background, Santa Claus is joyfully reading the book while playful reindeers peek in front from the sides, all set against a winter wonderland scene filled with vibrant red colors and festive decorations. So by using Prompty, you can very rapidly prototype and iterate until you have reached a state where you feel satisfied here with the results. So when you're satisfied with the results, then you can basically just copy these files here, the Prompty files, over to your Visual Studio solution. So let me go over here to Visual Studio, to the solution here for the example that we saw at the beginning of our session. Um, so here, here we can see. Here we can see a little bit more realistic example here of a solution, which has a number of different projects for some models and for observability, and also we have a specific project here for everything that is related to Azure AI. And in this project, we have a file, we have a folder here called prompts, and in this prompts folder, we have exactly the same files as I showed you earlier. This create image prompt and also the create rhyme prompt. So this is a very nice way here of going from prototyping in VS Code and then over to a more realistic example here in Visual Studio. So let me just drink a little bit here. So something that could be interesting here to see is here. So here we set up some services that we want to use, Azure OpenAI chat completion, and also text to image. Because remember here, we wanted to be able to send text to Dolly 3 and then return an image. And if you remember in the PowerPoint slide, I showed you that that right now it's only in the C# version of Semantic Kernel that enables us to use this text to image functionality. So after we have set that up, we add the kernel here, and we also add the Prompty templates, and we add some other service here by dependency injection. Like for example here, this rhyme service. So if we have a look at the rhyme service, we can see here that it takes in an input argument, which is the gift name. And then after that, it invoke this Prompty file that we have and the specific function name, which is the create rhyme, and also the arguments, which is the gift item. And then in the same manner as we saw here in VS Code, we are invoking this function here, and we get a rhyme back. And and then we can also see the same thing here for the image. So if we go here to the Christmas image, you can see here that this is also the input argument is the gift name, and we are invoking the kernel in order to create this function. And then after that, we are in this example here, the function here will be an image prompt, and then we send this image prompt over to a specific function here, text to image service. And then here we can specify also the dimensions here for our image. So that's the way that we get our image here to our application. But there's one small thing that I would also like to show you here. If I run this one more time here. So we're also running .NET Aspire here for this application. So if I run this one time here, maybe let's say that we want to have a tie, and then we can create the Christmas rhyme. Yeah, so here we can see that we also got the tie here back as an illustration. But what I would like to show you here is by using the .NET Aspire, we also get some information here for free. So among these things that we get here is, for example, here we can see here for our call into our LLM how many tokens I've actually spent here. So we see prompt tokens was 408, and then we have some completion tokens and the total number of tokens. And in addition to that, we can also see some more details here. So you can see values here. If we deployed it to Azure, we can get some different types of um, deployment information here, which can be very good here if you want to do debugging. So let me switch over here to the presentation. So I hope that you found this information interesting and that it made you curious to look into Semantic Kernel and look into AI agents. So if you want to know more, there is reference here to the official Semantic Kernel GitHub repo, where you can find these examples that I showed you and many, many more examples that you can try out at your own pace. And there is also a Microsoft Learn section on Semantic Kernel, the introduction to Semantic Kernel, and you can reach that also by scanning this QR code that you can see on this page. And yeah, before we do the Q&A, I can also show you here. If you're interested in following me or connecting on LinkedIn, please feel free here to scan this QR code to connect. So with that, I would like to thank all of you that has been watching this, and now I'm open to any type of question.
Yeah, thank you, Håkon, for presentation and demos that you showed. So uh, I don't see any specific questions on the chat, but I have a question like for somebody who is, let's say, just a newcomer to development, right? They are just learning how to develop. Maybe they are in the way to complete their computer science, studies in university. What would you recommend for those students to look into, get started
Mm,
with
mm.
implementing Azure AI services in small projects so that they can learn in the process? What would be your recommendation there?
Well, I think I would actually recommend looking into there's one specific certification called Azure AI Fundamentals,
Mm-hmm.
which is very much suited to a developer that doesn't necessarily have that much background in AI or machine learning, and it enables you to use some pre-ready-made services in Azure. So basically, as long as you know how to call an API, you will be able to use these AI services without you actually needing to understand in depth on how this services actually works. But that will give you a good understanding of when and how can such AI services be valuable. And I think it's a very good start for anyone interested in learning more about these types of concepts.
Yes, thank you for that. Uh, And from people in the studio, we have some people who are watching this live. So if you have any questions, this is the time now. Please put them in the chat so we can address. But while waiting for that, hopefully a couple questions to appear in the for us. I'll ask another follow-up question in terms of like hands-on skills, right? So part of it development is that you need to do some labs, maybe some projects, right, to get this traction with AI services and understand how you are going to utilize them in a different scope of the project that maybe you are going to get hired even because you are
Mm,
one step ahead of others in understanding those services how to implement. So from that perspective, is there any set of labs or projects that you would advise for new for developers who are new in this game of learning about how to apply
mm,
AI into day-to-day applications? What would be your recommendation there? And if there's any resource that you can share, that would be even better.
mm.
Yeah.
Yeah, yes, there is. So there is a resource um, if you search for, I think it's called generative AI School by Microsoft on GitHub, then you will be able to see. I think there is 21 different lessons that takes up everything from prompt engineering down to also agents in that. So if you Google a little bit around that, you will be able to find it, and that's a very good resource, and it gets continually updated. So right now, I think it's in its third revision, because you know that there are many changes both in
Hmm.
APIs, and also there are new models coming out, and also new concepts that we can take into use. So that keeps getting updated, and it's not the only school. There are also in a similar vein. There is also a front end school, and I think a back end school, and so on. So there's actually a lot of information which are completely free and open to anyone to try out.
Yes, I found like I looked at browser and there's like this on Microsoft Reactor YouTube channel. You have this generative AI on Azure dash the fundamentals part one. I believe there's like part two
Mm,
and part three are also going to come up. Uh,
mm,
so they talk about Azure AI Foundry, GitHub, code spaces, how to create
mm.
generative AI applications. So did you have a chance to look into that? Any recommendations from that series maybe that you heard about?
Yeah, there's actually there's a new series that Microsoft just released like a couple of months ago, which is called Ragtime. So if you
Mm-hmm.
Google Microsoft Ragtime, you will both be able to see a set of YouTube videos, and also the corresponding notebook with code that you can run yourself to try it out. So it's both like a GitHub repo and also some YouTube videos, and they're going through sort of the fundamentals into what is a reg application, and what is search, and different types of search, and how you can improve your search using Azure AI search or document intelligence and other kind of tools. So I can highly recommend that too. But I think if you're just starting out, I would probably start out with Microsoft Learn, and just try to go for this Azure AI fundamentals. Even though maybe you don't want to take the certification, the learning path is for free. So you can do the learning path without paying anything, and you will still be able to get a lot of valuable knowledge and a good starting point there.
Yeah. All right. Definitely. That's really good. Suggestions there. Thank you. Again, thank you everyone for watching our session today with Håkon, Microsoft MVP and AI evangelist. It was a very informative session with a lot of demos here and there that I believe can give you some insights into where to start and where to look. And plus, at the end, we discussed this great resources, right, that are there free, available for you to get started in your AI development journey. And if you have any questions, Okan also sharing his LinkedIn profile here. So feel free to ping him, and I'm pretty sure he will guide you in the right direction there. Thank you, Okan, again for your presentation. Thank you, everyone, for watching this. Have a great day, everyone, or maybe great evening. See you all on our next session. Thank you. Thank you, everyone.
Thank you. Have a good one.